Hey, I'm Josh, and thanks for checking out my poster. Here, I'm showing results from a paper we recently published about an unbiased search for polarized radio emission with the Australian Square Kilometre Array Pathfinder. This project was part of the Rapid ASKAP Continuum Survey, an all-sky radio survey at 888 megahertz that has now become the best view of the radio sky at centimetre wavelengths below a declination of plus 41 degrees. We searched this survey for radio sources with high degrees of circular polarization, a property that's only associated with a few classes of astronomical objects, including pulsars and the magnetospheres of stellar and planetary systems. As part of this search, we identified 33 radio stars with a significant degree of circular polarization, including magnetically active M-dwarfs, pre-main sequence stars, interacting binary systems, and magnetic chemically peculiar stars. And 23 of these have never been reported as radio loud in literature. The left plot shows the fractional circular polarization and flux density of these detections, along with 37 pulsars and 6 as yet unclassified sources. We derived lower limits of the brightness temperature of these detections in order to try and constrain the possible emission mechanism. These are shown in the right plot for each variety of star, along with empirical models of the maximum brightness temperature attainable for optically thin, non-thermal gyrosynchrotron emission. While the interacting binary systems are consistent with these models, the majority of our detections are too bright and polarized to be explained by the gyrosynchrotron emission or any other incoherent emission mechanism. They're instead likely driven by a coherent emission mechanism, such as the electron cyclotron maser, which is responsible for beamed auroral radio bursts from Jupiter and stellar magnetospheres, or plasma emission, which is responsible for a range of solar radio burst phenomena. Both of these processes are excellent probes of stellar magnetospheric properties that are in turn important measurements to aid models of dynamo theory and space weather, for example. This survey detected roughly 1 star per 1,000 square degrees. Future ASKAP and SKA surveys will produce much larger samples, allowing robust statistical properties, such as the burst luminosity function and duty cycle, to be derived. You can scan the QR code if you'd like to check out the paper, and thanks for your interest.